So today I wanted to do another example with Mohr's circle, and specifically today we are going to basically determine the rotation required to get to the principal and maximum shear stress states for the 1, 2, 2, 3, and 1, 3 planes for a given stress state. We're going to write out the stress tensor for some arbitrary rotation, and we're going to find essentially the values of the principal normal stresses sigma 1, sigma 2, and sigma 3, and the maximum value of the maximum shear stress. So let's get to it. So let's consider, for example, we have a stress tensor that's the following. And again, in values of megapascals. So we're going to have 29, 0, minus 51. Excuse me, sorry. Let's make this a little bit nicer. 29, 0, minus 51. And then we're going to have 0, 0, 0, and minus 1, 0, minus 27. So let's draw out our three basically Mohr circle plots. Tau, sigma, and tau, excuse me here. Tau, sigma. So just like last time, we are going to let's do this as, so that is, blue is going to be 1, 2. We're going to have, this is going to be our 2, 3. And then finally, these puppies are going to be 1, 3. So let's start off and draw 1, 2. That is a nice one. So again, we're going to find our coordinates. So right here, we have a position at 29 megapascals, and then at 0. So this is our stress state, this point, right here. We draw our Mohr circle, and that's it. So what rotation is required to get to our maximum principal stress state? We're already there. So we know that sigma 1 is equal to 29. We know that sigma 2 is equal to 0 megapascals. What is the value of this kind of maximum? What's the rotation to get to the maximum shear stress? Well, we're going to rotate 2 theta. Again, clockwise or counterclockwise. That 2 theta value is going to be what? How many degrees? It will be 90 degrees. So the theta will be 45. So in real space, that's to get to our maximum shear. The value here is just going to be 29 over 2. And that's it. So we've got kind of the principal values here. So for maximum principal normal stresses, the rotation is 0. The rotation for maximum shear stress, 45 degrees in real space. Let's do 2, 3. Another nice one. 2, 3. What are my values? 0, minus 27. Point here, point here. Again, what's our sigma 1? Not 27, remember, it's the sign. So sigma 1 is 0, sigma 2 is minus 27. And what are we left with? We're in our rotation, we're in our maximum normal stresses. To rotate to our maximum shear stresses, again, it's the 2 theta of 90 degrees. And our value is here, 27 over 2. To get to this value for maximum shear. Nice. Now, 1 and 3, not as easy. So we're going to have this value of 51, not to scale, 51. We are going to have 29 on this side, minus 27 on this side, and we'll have our 4 points like so. And our circle will kind of go through, you know, not the most skilled drawer, as you all know by now. It's going to go through here. So we need to figure out, okay, where is our center so that we can figure out what is this 2 theta value, what is our rotation to get to our maximum normal stresses. So we can remember, or we could use in Mathematica, our center is just going to be basically these two values added, so 29 plus negative 27 over 2. So the center value is going to be what? It is going to be equal to 1. So that is our center. So the center is located at positive 1 right here. So let's look at our triangle so we can kind of figure out the rest of these values. So our right triangle is going to be, let me draw it here. We're trying to find this to theta. We know that this distance is 1 minus 29, so this is going to be 28. We know that this distance here is going to be 51, so now we just have to solve for r. So we can do that, and actually you can do that in Mathematica, and I will figure it out yourself. So let's do, so it's just going to be, we need to solve for tan of 2 theta is equal to opposite over adjacent, 51 divided by 28. And we can solve that, and actually, I'm going to go ahead and just give you the answer once I solve it for, I'm doing this on another computer. Theta is equal to 215 by 28. Solve for theta. And what you'll get is a value here. 10. This 1 second here. E divided by pi. And what you'll get, you'll find that theta is equal to, if you do finish the math, 30.616. So we need to rotate 2 times that in the, again, clockwise direction in order to basically reach our value here. So we are going to rotate clockwise there, and yep, so that will be your rotation. So once we do that, then we'll rotate, we'll have our principal normal stresses. So our sigma 1 here is going to be our center 1 plus the value of this radius. So the radius is just going to be, again, we had solved that using kind of geometry. So we're going to do the square root of 28 squared plus 51 squared, Pythagorean's theorem. Let me get this value, and we'll kind of write it down here. So our radius is going to be equal to 58.18 megapascals. So that's that value. So our sigma 1 is going to be our center. So it's going to be basically 59.18. And then our sigma 2 is going to be, oops, excuse me, 8. And our sigma 2 is going to be equal to 57.18, approximately. So, or actually, excuse me. So remember, it's minus 27. So it will actually be, excuse me there. It will be quite a bit different. So 1, because again, it is going to be your value, the center minus that value. So it will be minus 57.8. There we go. So, because minus your radius, so 1 minus this is going to be minus 57.8. So those are our 3 values. So we need to now figure out, okay, well, what is our, I'm going to erase this here. Actually, let's see where I can erase. Yeah, I'm going to erase it this. Actually, I'm going to write it up right here just as. So what is our sigma 1? So what is our largest value of sigma 1? So here, here, or here, it is going to be equal to 59.18. What is going to be our value of sigma 2? What's our largest value of sigma 2? Well, it's going to be 0 there. Because again, we're looking at the sign, so we're not concerned, we are not concerned with basically those, again, the magnitude or the absolute value. We're looking at the sign, so it's going to be 0. And sigma 3 is going to be the smallest of these. So here and here. Well, that's going to be, sigma 3 is going to be equal to minus 57.8. So those are your values. That's it. So we can draw now your 3D kind of Mohr circle. So I'm just going to erase this guy right here. And I can draw tau stress. So I have a point at sigma 1 way over here. I've got my sigma 2 right there. And I've got my sigma 3 over here. So I've got a circle here, I've got a circle here, and I've got a huge circle over here. So what's the value of my maximum shear? This value right here at the top, that's just going to be, again, the radius of the circle. So sigma 1 minus sigma 3 divided by 2. That's it. So that's how you draw the 3D Mohr circle. That's how you find the location of the principal normal stresses 1, 2, and 3, and the value of the maximum shear stress. Those are all the quantitative values. Now let's say that I wanted to do, again, some rotation, some arbitrary rotation with this matrix. Well, let's say I wanted to rotate it, let's say 57 degrees counterclockwise. Well, I would just go back into Mathematica. I'm going to change my kind of stress state. So I'm just looking at the value that or the matrix that we kind of made previously. So I'm just going to adjust it so it's consistent with the one we were working with. And we could see that we're going to get essentially all the same kind of results that are consistent with what we just saw. So 0 minus 51, 0 minus 27. Right here, and we could redefine essentially these values. We're not going to kind of bother with this stuff. But instead, if I want to do my, what is my stress tensor at some rotation, let's say 57 degrees counterclockwise. So stress theta, change it to 57. That's it. That's how you do that rotation. Let's try to plug in again. What if we did T matrix dot stress? We said that the value was approximately 30.61 to get to our maximum principal stress. So let's confirm. Theta goes to 30.6162. Actually, this was for basically kind of one value here, but you could kind of check that on your own time. But let's see and make sure that if I do my eigenvalues of stress, what are those values going to be? 59 megapascals, minus 57 megapascals, and 0. The exact same values that we kind of saw for our sigma 1, sigma 2, and sigma 3. Just kind of how we saw. So again, multiple ways to kind of solve and basically confirm your answers here. So yeah, that's basically it. So you can kind of double check that. If you wanted to, what I was trying to do here is let's take out, we were interested in the 1-3 plane. So I want to do stress, 1-3. It's going to be equal to 29 minus 27 minus 51 here. And then my angle, I do T matrix dot stress 1-3 slash dot theta goes to 30.6 162. Let's go to minus here, and you see again because we need to rotate in the other direction. You get approximately again, this is basically our answer. We have 59 minus 57, 0. So 0 here because again we're in our maximum. That's the angle we had to rotate to get to our principal normal stresses. Again, clockwise rotation, and that's it. We're good to go. So that's just another way to do more circles. So hopefully that kind of clears up and gives you some additional practice problem. If you need more, please let me know. But otherwise, have a great day. Bye.